Hello. Okay, let's look at solving exponential functions. And I'm going to do this example three different ways. And I encourage you, try all three. Whichever one kind of feels natural to you, go for it. But maybe if you can learn at least two of these three techniques, then you've got another double checking method. So solve it one way, use a different solving technique, double checking, see if you got the same answer. Because these answers are going to be a little complicated looking, you're still going to need to type it in the calculator, but you're not going to have to type it in as the exponent. You'll get to the end and you go x equals this, type it in the calculator, you solve it differently, x equals, type it in the calculator, same decimal, same answer. All right, so for this particular one, we're going to use this idea that as long as we do the same thing on both sides of the equals, we can do whatever we want. We want to do something appropriate. So for example, taking the square root on both sides doesn't help us solve it. So don't do that. But if I apply a logarithm, then I can use all of those logarithmic rules and properties and things to help me solve it, which is a good thing. So, and you can do any logarithm. I always do the natural logarithm. You can do the common logarithm or possibly the same base logarithm as the exponentials that we've got. I would not want to do log base pi on both sides and make it more complicated. But if I did log base 3 or log base 2, and I encourage you to try those and see if those make sense. But I'm going to do the natural log on both sides. Whatever logarithm you choose, the next step is we have this exponent in the argument of the logarithm, and we've got that rule that says I can take that and make it a coefficient in front of the logarithm. If you've got more than a single thing as the exponent, distribute in the next step. So on the left side, I'm distributing. You want to combine the x's together and move the things without an x to the other side. So when you're doing this, consider how many minuses and negatives you'll have on either side. If I take the x natural log 2 and I want to move it to the left, I'm going to subtract it. And then I'm going to have to subtract the natural log 3 to move it to the right. So I've got a minus on the left and a negative on the right. Whereas if I subtract from the left the x natural log 3, then I'm just going to have that minus on the right side. So if you pause here and go, do I move it to the left? Do I move it to the right? Think about the quantity of negatives and minuses. The fewer, the better, like that. Factor out the x. Now everything in the parentheses on the right side is just a coefficient of x. Now if you want to do some of the simplify, you know that when you subtract different logarithms with the same base, you can combine the arguments by dividing them. You can do that if you want to. I'm not going to bother. I'm done. All right. I'm going to turn the page and do another technique. Remember, these alternate techniques can be used as double checking, but it's always good to double check your answers in some way because there's a bunch of steps there. You could have done something wrong. Little mistake.